Hello, this video covers the lecture part of Lab 7 in electronics. In Lab 7, we're going to talk about Zener diodes and one basic application for Zener diode, which is voltage regulation. On the right-hand side, you see the symbol, the circuit symbol for a Zener diode and an actual image of a Zener diode. Notice that the difference between a regular diode and a Zener diode symbol is just this part of the circuit symbol. We're going to start by first explaining the difference between a Zener diode and a regular diode. Notice that in the forward bias region, a Zener diode and a regular diode act the same. They both start conducting current once the voltage across them exceeds Vd, which is approximately 0.7 volts. So this is Vd. However, in the reverse bias region, a regular diode doesn't conduct current, while a Zener diode also doesn't conduct current until the voltage across it reaches what's called the Zener voltage or the breakdown voltage. Another name for it is the avalanche voltage or VZ. That's when a Zener diode is going to start conducting current in the opposite direction. One basic application for a Zener diode is voltage regulators. On the left-hand side, you see the basic circuit for a voltage regulator circuit. RL is the load resistor. So the actual voltage regulator circuit stops here. And then if you are to plot V out versus Vin of this circuit, you're going to find out that V out is going to increase linearly with Vn until it reaches this point, which is the Zener voltage. So if you are to design a voltage regulator circuit that depends on a Zener diode, then the output of the regulator circuit is limited to Vz. So it increases up to a certain point and then stops at Vz. So that is going to be the limit of the output voltage for the regulator circuit. When we're using the Zener diode as a voltage regulator, we're depending on this part of the IV curve as our operating range. Observe that the line here is not exactly vertical, but rather it has some slope. Thus, we need to introduce a new definition, which is the line regulation. Basically, the line regulation is a measure of how efficient our voltage regulator is. So we can define it or calculate it by measuring the changes in the output with respect to the changes in the input. Otherwise, differently put, we can say it's equal to delta V out over delta Vn. And we simply need to measure 2 points or 2 values for V out with the corresponding values for Vn, and then simply plug in them in here by putting V out, the second measurement, minus V out 1 over Vn2 minus Vn2. Notice minus Vn1. Notice that the line regulation is unitless, or you could also multiply the result by 100% just to give you a percentage at the output. There is another way to calculate the line regulation, and you can figure it out by applying VDR on the circuit itself from your knowledge on ELEC 220. You will find out that the line regulation can also be calculated using the formula RZ, which is the Zener diode internal resistance, over RZ plus RS. Notice that if the load you're connecting at the output here, for example, RL, is small enough, you'll need to replace RZ with RZ in parallel with RL. However, if RL, the load resistance, is large enough, then you can ignore ignore it, because if you calculate RZ in parallel with RL, it will be closer to the value of RZ. So just to summarize again, if RL is much greater than RZ, then you can ignore it. Then ignore RL and just simply use this formula. If RL is small enough, then you'll have to replace RZ in this formula with RZ in parallel with RL. This concludes the lecture part of Lab 7. For now, you can download Lab 7 sheet for Moodle, complete the experiments, make sure that you do them individually, and then ask questions if needed. To help me check your work and verify it, please share your screen with me when you're ready. And you may also share your screen if you have a question that needs me to see your screen and your work as well. Finally, upload the complete sheet to Moodle for grading. Thank you for watching. If you are watching this live and have a question, you may type it in the chat. Otherwise, you can email me at alatia@auk.edu.kw.